Okay, so this is the ACT Aspire Mathematics Post-Test. Okay, we'll do the multiple choice first. Number 1 says, which of the following transformations gives an image that is similar but not congruent to the original figure? Remember that congruent means that it is the same shape and the same size. However, the word similar means the same shape but not necessarily the same size. The answer is A, a dilation by scale factor of 1/2. If the scale factor is less than 1, it reduces the size of the image. If the scale factor is larger than 1, it's an enlargement. So that changes the size, which would mean it is similar. B, C, D, and E are all positional transformations, so the resulting images are congruent to the original figure. They're just moved around. Number 2, students must choose one of 5 books for their next book report. The books have 218, 180, 240, 164, and 128 pages respectively. What is the range in the number of pages per book? The range in this case means what is the spread of data, and that means what is the difference between the largest number and the smallest number. So the largest number there is 240 and the smallest number is 128. If you subtract those, that tells you the range is 112. So the answer is E. Number 3 says solve this equation. 3 times 8 minus x equals negative 6x plus 15. So the first thing that we're going to do is distribute. 3 times 8 is 24. 3 times negative x is negative 3x. Then I usually like to get my variables together. You can get the constants together first if you choose, but I always like to get my variables together. That way I can get those taken care of. So I'm going to move all of my variables to the left-hand side. I'm going to do that by adding 6x to both sides. The 6x's are gone from the right-hand side. On the left, I have 24 plus 3x, and then equals 15. Now I want to move the 24 to the other side. I'm going to do that by undoing the 24 by subtracting 24. So now I have 3x equals negative 9. And when I divide by 3, my final answer is x equals negative 3, which is A. Number 4 takes a little bit of thought. It says Monica works 40 hours per week at 2 different jobs. She works H hours per week at the first job and is paid R dollars per hour. At her second job, she is paid S dollars per hour. Which expression gives her weekly pay from the 2 jobs? Okay, first of all, let's write down what we know. We know that she works 40 hours total, and that's between both jobs. Let's look at that. That's job number 1. It says she works H hours and earns R dollars. At job number 2, all it tells us is that she earns S dollars. It doesn't say anything about the hours. Okay, to calculate the amount of money that you earn at a job, you take the number of hours and you multiply it by the amount that you get paid per hour. So for job number 1, it is R times H. Job number 2, we don't know how many hours, but we do know how much she gets paid per hour, and that is S. We don't know specifically the amount of hours, but we do know that the total hours for the week is 40, and for her second job, it's H less than that 40. So her second job is 40 hours minus whatever she makes at the first job, which is H. If I take the first job and I add it to the second job, that's going to give me her total amount? The answer is A. Now it looks a little bit different, but right here I could switch those. That's a multiplication problem. Remember, multiplication you can do in any order you want. So I could write this as RH plus 40 minus H times S. Either way, it's the same, and the answer is A. Okay, number 5 says, which data representation is best designed to show the changes over time in the price of a particular stock? The answer is A, line graph, because time is a measurement and it's continuous, so we would use a line graph. B is a bar graph, and bar graphs are used to compare quantities, specific quantities, discrete numbers which are countable, not necessarily measurable, and they could compare categories. C, a stem and leaf plot, is used to organize numbers by their place value. This is very handy when trying to find different measures of central tendency. Box and whisker plot divides the data into quartiles, into fourths, to show the distribution of the data. And E, cumulative frequency tables keep a running total of frequencies or number of times an element occurs. So again, A, line graph. Number 6 says, on a trip of 525 miles, how many minutes faster is it to travel at 60 miles per hour rather than 50 miles per hour? Now, sometimes you have to make sure and read the answer, the question carefully. It says how many minutes faster, and then it gives the speeds in miles per hour. So you've got a couple of choices. You can change the 60 miles per hour and the 50 miles per hour into minutes per hour, or you could just figure out how many hours it takes at both of those speeds and then convert to minutes, which that's what I'm going to do. So it's 525 miles, and we have 60 miles per hour, and we're going to compare that to 50 miles per hour. So first, to find out how long it took us to go 525 miles going 60 miles per hour, you do 525 divided by 60, and that's 8.75. That's 8.75 hours. And we need to find out how long it took us to go that 525 miles, 50 miles per hour. That's 10.5, which should make sense. It took us longer to go at 525 miles because we were going slower. So the difference between 8.75 and 10.5, we're going to subtract 10.5 minus 8.75. That gets us 1.75. So it took us 1.75 hours fewer to do the 525 miles. But the question was how many minutes faster. So 1 hour is 60 minutes. 0.75 is 3/4 of an hour, which is 45 minutes. So when you put those together, you get 105 minutes, which is D. Okay, number 7 says mercury in its metallic form has a melting point of negative 38.9 degrees Celsius and a boiling point of 356.6 degrees Celsius. How many degrees higher is the boiling point than the melting point? Okay, normally when you're finding out, you're comparing two numbers, you usually subtract. However, one of our numbers is negative and one of them is positive. So what we will actually do is add the distances that the numbers are to 0, in other words, the absolute values. So I'm going to draw a little bit of a picture on a number line. It's not very straight. So the boiling, or the melting point, is negative 38.9 degrees Celsius, and the boiling point is 356.6 degrees Celsius. And we want to find how many degrees higher the boiling point is. So 0's in here somewhere. So we're going to find how far it is from the melting point to 0, which that's 38.9. And then we got to go the rest of the way, which is 356.6. So we're going to add those numbers. So 38.9 plus 356.6. 395.5 degrees, which is C.